Secure electric distribution in today's world is imperative. Faster and safer operations are essential, and if there's a power outage, it is crucial to be able to restore power quickly and smoothly. Protection relays are an essential part of power systems. They detect faults in the system and act quickly, within milliseconds, to protect the circuits, equipment, and personnel. Also, maintaining the relays must be done swiftly to ensure the shortest possible downtime of the main process. ABB has placed special emphasis on combining the latest technology with high usability. Watch this video to discover the easy and cost-efficient engineering of ABB's Relion 611 series. When a protection relay detects a fault in the power system, it reacts to it, for example via operating the circuit breaker, and sends information, known as events, to the centralized control system. Typical fault situations are when an earth fault has occurred or there is an overcurrent in the feeder. During a local blackout, the electrical system operator immediately contacts the service personnel to direct them to the related substation. From the line of switchgear panels, the electrical feeder in question is easily located. The LCD display and the alarm LEDs on the front relay panel indicate that the circuit breaker has tripped and that there was an overcurrent fault situation. With the Relion 611 series protection relays, a regular laptop can be used to operate the device. No additional tool installations are required to use the relay's web HMI. All the data needed for fault analysis can be accessed through the web HMI. All recorded data is available under the Report Summary tab. Here you find lists of settings, fault records and events, and also disturbance records in standardized format. To make further analysis easier, this data can be directly saved as one compressed file and stored on your computer. Additionally, under the Import/Export tab, you can save the current relay settings in XRIO format. If required as a precaution, the protection relay plug-in unit can now also easily be removed for further analysis. When detaching a relay plug-in unit, the auxiliary voltage must be switched off. Ensure that the replacement unit is an exact match through verifying the order codes of both units. The settings that were stored on the computer can now be written and stored to the replacement relay. The complete replacement procedure takes only a few minutes. If required, additional testing can also be done to verify that the relay operates correctly. The power can now be restored by closing the circuit breaker. The indication on the front panel shows that the situation is back to normal. When the power has been safely restored, the collected data can be further investigated to analyze the situation fully. The replaced relay can be tested and the disturbance recorder data used for simulation of the fault situation. We will continue on this a bit later, but first, let's take a closer look at the Relion 611 series. There are 4 relay types: the REB 611 for bus bar protection, the REF 611 for feeder protection, the REM 611 for motor protection, and the REU 611 for voltage protection. These protection relays are pre-configured for fast setup and commissioning. Once you have entered the application-specific parameters using the web HMI, the relay is ready to be put into service. It is also possible to use ABB's PCM600 engineering tool for this. All the relays of the series are compliant with the IEC 61850 standard. Also with Edition 2, communication also runs smoothly with other manufacturers' products which comply with the standard. All connections to the relay are made on the rear. The protective earthing screw is located on the lower part of the case. 4 different communication modules are available for wired Ethernet, fiber optic or serial communication. Supported communication protocols are IEC 61850 or Modbus, or both simultaneously. Depending on the relay variant, additional input, output, or voltage measurements can be found on the optional X130 module. To start using the Web HMI, you only need to connect your laptop to the front communication port with a standard RJ45 Ethernet cable. In your web browser, enter the IP address. For full access, log in with your administrator username and password. In the Web HMI, you can perform all necessary actions, such as configure the signals and define binary input and output signal connections, modify protection-related parameters, modify application-related settings, and access event lists, disturbance records, and fault records. To configure input and output signals, click the corresponding area to view a specific logical group. The switch groups included in the logical group then become visible. Use the Overview button to display the signal configuration overview. When changing the settings via the Web HMI, it is important that you enable Write to be able to change the parameters. To change a connection, you can simply click on the connections in the matrix to disconnect and connect. The recent changes in the connections are displayed with different color and size. They can now be written to the relay. Select Commit to store and take the changes into use. The binary output signals contain certain pre-configured signal groups that can be changed in a similar way. All connections can be printed, for example, to a PDF file for documentation. To set the protection-related parameters, go to Settings, Current Protection, Overcurrent Protection, and type in the changes. To specify application-related information, go to Information and Site Identifiers. When all settings have been made, it is possible to test the protection relay by injecting current with the testing device. Start, trip, and events can be seen on the relay and also in the Web HMI. During the simulation, you can view the 3-phase currents in the phasor diagram. The fault situation can be further investigated from the Events, Disturbance Recorder, and the Fault Recorded Data. The local HMI consists of push buttons, a graphical display, a front communication port, and alarm LED indicators. It is used for parametrization, monitoring, reading measurements, and controlling the primary equipment. The collected data is verified against the results retrieved from the bench test. The fault was found caused by an overload in the feeder. There are many benefits with the Relion 611 series. The easy-to-use and versatile Web HMI. the pre-configured solutions for cost-efficient engineering and commissioning, and the withdrawable plug-in unit for swift installation and testing, which results in faster mean time to repair. To learn more about the versatile Relion protection relays, please visit www.abb.com/Relion.